Hi class, Assalamualaikum and good day to everyone. For today, we will look at the examples how to calculate the member forces of truss using the method of joint and also together with the determinacy. At the end of the class, you able to check the stability and truss determinacy and also how to calculate the member forces of truss using the method of joint. These questions is the examples of the problems for today. The first thing when you got these examples, you need to check the determinacy of truss. Okay, first using the equation of M plus R equals to 2J. So from here, we can find the member truss is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And the total of reaction, here we have pin supports, which is 2 unknowns, and this is a roller support, which is 1 unknowns. The total of R is 3, while the joint is here 1, 2, 3, 4, 5, 6. So we have 6. Okay, so 2 will be multiplied with 6. We will have the truss is determinate structure. Okay. Okay. The next one, you need to find the member forces. So the question is which joint you need to start. If you look at here, the requirements to start using the method of joint, you can choose at least have 2 unknown member forces. So if you look at the requirements of method of joints, at least 2 unknown member forces, you can start from joint A or you can start from joint B. But you need to find first the support reactions. Okay, so if you look at here, we can choose a moment at A. Okay, you also can choose moment at B. If we choose moment at A, so it will be, because we assume clockwise is positive, so we will have 8 multiply with the distance from point loads to the point of moment, which is 4. And then here we assume the support reaction direction is upwards, so we will have negative Phoebe. Okay, because of the direction is upward, that will move around point B in a counterclockwise. That's why we say it's positive. And we multiply with the distance 5, 4, and 4, which is 13. Okay, 13. And we also have another point load in horizontal direction. This one is positive 6 because of the rotation is in clockwise. And we multiply with the distance, which is 5 meter. Okay, so from here we can find the support reaction. So we have VB, okay, is 4.77, okay, kilonewton, and direction is upwards, while VA, which is support reaction at A, we have 3.23, which is direction upwards. Okay, here we have a pin. So pin here will be 6 kilonewton, due to the external forces, which is 6 kilonewton here in horizontal. Okay, then you can start using the method of join. So if we start at join A first, so now we will have the member forces of truss. So here will be AC and AF. So this one is AC and AF. Okay, to solve using the method of join will be based on equation of equilibrium. Okay, so which equation that you want to start, fx or fy? So if you look at here, the member truss, this one is in the x direction, which is fx. Okay, and AC is in fx and fy. So if you look at these three, we only have one unknown in y direction. So we can start with the equation of fy. So using the equation of equilibrium, upward equal to downward in y directions. So we will have, if we look at here, upward we will have 3.23, which is support reaction. And then we also have AC, which is in upward direction. Okay, so we will have AC, and the angles here, okay, is a 51.34. Okay, so we have cos or sine. This one is y, so we choose sine 51.34. Okay, while fy in upward directions, we don't have it, so this one is 0. Therefore, we will have member forces of truss of AC is negative 4.13 kilonewton. So this signs of negative here, meaning that the member of AC is in compression forces. Okay, now we look at the Fx. Okay, because we don't find yet the member forces of AF. So equal left equal to the right. Okay. Okay, now we have AF. AF is in X direction, which is no angles involved. And we also have AC. This one, this time will be cos. Okay, 51.34. And then we have external, which is 6, so equals to 6. So AF will be 8.58 kilonewton in tensile force. After we finish join A, so which join that you can continue to find the member forces? So you can start from left to the right, okay, or you can jump to another join, which is B, because join B also have two unknown member forces. If you want to choose join F, so this one will be, this is how your members looks like. Okay, so from here we don't have the angles, which is we can find directly from the diagram. So FA we already determined previously. We have Fy upwards equals to downwards. So we have 8 is downward. Okay, and we have FC is upward, so this one will be FC. So FC member forces of truss will be 8 kilonewton, which is in tensile forces because of the positive, while fx directions. Okay, so we will have fe and then equals to left and to the right. So we have 8.58. So Fe member forces of truss, we will have 8.58 in tensile forces member. Okay, now if you look at here, we already find this member forces, this one, and this one. Okay, so the next joint we can start at B. So this one is referring to the joint B. So here we have members of BD and also the BE. So which equation of equilibrium you can start? Fx or Fy? BE is Fx direction. Okay, unknowns. BD because we have the angles. While member BD we have two unknowns, which is in Fy and Fx. So from the comparison we can say only have one Fy. So we start with Fy. So Fy upwards equal to Fy downwards. Okay, so we will have upwards 4.77 and also BD direction, which is upwards BD, and it will be sine 51.34. So we will have BD. Okay, this one will be a compression due to the negative value. So BD will be 6.11 kilonewton. The truss member forces is in compression. Okay, after Fy, we go to Fx, okay, because we don't find yet the member forces of BE. Okay, so this one will be Fx. So here we will have BE, okay, and also BD. We have BD, this term is cos, okay, and also 51.3. So we will have the member forces of PE is 3.82 kilonewton, which is in tensile forces. Okay, so now we done BE and also member forces BD. Okay, so next one we can choose member D. If you look at here, we already find member forces for DB. Okay, so DC and DE we need to find. So this one, if you look at here, both DC and DE, they don't involve the angles. We can start Fy or we also can start Fx. Okay, so if we start with Fy upwards equals to Fy downwards. So here we have downwards DE, okay, and also we have DB. So DB will be, theta here is 951.34. So DB here will be sine, okay, because of Fy direction, 51.34. here we will have DE 4.77. So this one, member forces of DE will be in tensile forces. How about DC? We don't find DC yet, so we choose another Fx. Okay, left equal to the right. So here we have dB cos 51.34. Okay, and then equals to DC. Here we have DC is in negative, okay, 3.812 kilonewton in compression. Okay, so member DC is done, member CD is done. So we only have one member forces need to find, which is CE. So this one, for the method of join, you can choose E or you can choose C. So if we choose C, so this one will be the last join, join C. So if you look at here, they will involve 4 members. So far previously, we already find the value of CA, CF, and also CD. So you just put the value here, okay? Because this one we already find. So only CE we need to find. So which equation of equilibrium you can choose? So since that CE involve the angles, so we have Fx and Fy unknowns. So we can start with Fx, or we also can start with Fy to find the member forces of Fe. So if we choose Fy, okay, upwards, as usual, upward equals to downward, downward. So here we have CE is 6.75 kilonewton. Okay. In compression member because of negative value. Okay. After you got all the member forces, okay, so how to know all the member forces that you already calculated is correct? So this one you need to do checking. Okay, you need checking. So if you want to check, you need to choose one joint which is involve critical member, or you can choose the joint which is involved many member forces. Okay, so if you look at here, we can choose joint C. We can check, do we got the balance forces or not balance. So if we choose Fx, okay, so Fx to the left equal Fx to the right, okay, you just choose equation of equilibrium. Do we have another direction, CA, which is negative 4.13 cos 51.34. And from here we can find that Fx at the both direction is balanced. Okay, so if balanced, so meaning that your calculation is correct. Then you can continue Fy. Okay, you also need to check it Fy direction, do you got equal or not? Okay, thank you for today. Please subscribe my YouTube, so I will share with you more the examples of truss determinations calculation.